Today we're going to talk about similar triangles. This is in section 7.4 in your textbook. If you need to review in your textbook, it is totally highly recommended. Similar triangles. You are given that triangle ABC is similar to triangle DEF. Identify each statement as true, which must be true, or false, false meaning could be false. You might find a little picture helpful. So we will start and line these up with ABC and line them up with DEF. We'll do a few of these and the rest you can fill out, and we will go over the rest of the answers in class. You are given that triangle ABC is similar to DEF. Is angle A congruent to angle D by definition of similarity? Well, angle A and angle D live in the first position in this statement, so that would mean they are corresponding, and the answer would be true. BC and EF. BC is the segment here, DF is the segment here, or you can look at it in the picture, and that is also true. We'll skip C and we'll go over that in class. What about triangle BAC and triangle DEF? Well, does angle B line up with angle D? No, so the answer for this one would be false. And the rest of these we'll fill out in class and go over the answers. Review. Two polygons are similar if corresponding angles congruent, corresponding sides proportional, which means there's a ratio that you could set up for equivalence. From the investigation that you guys did when you cut out your sides of triangles, you found a few things. For triangles, only triangles, which are a part of a polygon, in the family of polygons, knowing just one of the two things is enough. Knowing just one of the two things above is just enough, In other words, SSS similarity says if you have two triangles where all three sides are proportional, the triangles are similar. Angle, angle, angle similarity says if you have two triangles where corresponding angles are equal, the triangles are similar. And side angle side says if you have two triangles with two pairs of proportional sides and the angles between them are equal, the triangles are similar. We may be proving these a little later, but for today we'll just take these as givens, and we will try to use either side, side, side similarity, angle, angle, angle similarity, or side, angle, side similarity for discussion on the below example. In each triangle below, triangle ABC is similar to another triangle. Explain why they're similar using the correct order, what the scale factor is, and then find the value of x. Okay, so let's look at this one. All right, we know this symbol means that these two sides are parallel. And let's see, so we have 6, 4, 12. We don't have any angle info, but we know that angle A is congruent to angle A by reflexive. Angle B would be congruent to angle D by corresponding angles congruent if sides are if segments are parallel. And likewise, angle C is congruent to angle E by corresponding sides congruent. So by angle, angle, angle similarity, we can say triangle ABC, now we have to line it up correctly, is similar to triangle ADE. And the scale factor, we'll have to look at the sides of the triangles. So we have 6 here, we have 10 here. So the scale factor would be 6 to 10, which we can simplify by dividing this by 2 and dividing that by 2, so we'll get 3 to 5. Okay, next one. Triangle ABC and similar to, okay, now this one we're not given any angle information. Oh yeah, we are actually. We're given 40 and 60 and x, but that's it. Oh wait, we have to find x here. Whoops, let's do that. All right, so we know that 3 is to 5 as x is to 12. That would be the same corresponding sides proportional. 36 equals 5x. X is 36 over 5, which is 7.2. All right, now going over here. Well, we don't have enough info about the angles to determine if these are similar by angle, angle, angle similarity, so let's work on the sides. So what I always think of is that we check the smallest side, which is side 10, which has a length of 10. We compare that to 12, which is the smallest side in the other triangle. We take the medium size, which is 15, or the next size up, and compare that to 18, and we compare 20 to 24. So if these ratios or these proportions are all, if this proportionality is all congruent, or this statement is all true, we can say that these two triangles are similar. And again, we must match smallest to smallest, middle to middle, and largest to large. So let's see, we can simplify this as 5 to 6. And if you look through here, oops, I think I made a mistake on this one. This is not 45, it's 24. So 5 times 2 is 10, 6 times 2 is 12, 5 times 3 is 15, 6 times 3 is 18, and so forth. So these are actually all true. So the reason that these are similar is side, side, side similarity. And let's see. So again, if we want to say ABC, that's the middle, the large, and the small. So we have to find the middle, the large, and the small. So it would be EFD. So we have to be careful when we line up these sides. The scale factor for this one is 5 to 6. And finding angle X, which is D, would be the same as angle C. Oh, we don't have enough, but we know angle B is the same. This has to be 60 because angle B is the same as angle F. And so the leftover has to be 80, which means that X is 80, which is angle D, which is also lining up with angle C. All right, last one. Triangle ABC. All right, let's look at this picture. Well, let's see. We're given some side info. We're not giving much angle info, but if you recall, these two angles are vertical, and vertical angles are congruent. So let's see. So maybe we can use the side angle side similarity if we can match up the sides. So let's see. Now again, we take the smallest side in the left triangle, which is 6, and we match it up with the smallest in the right triangle, which is 12. We match that up with the smallest on the left, which is 7, and then the next one is 14. So that is looking good for a scale factor of 1 to 2. Now we just have to line up carefully the sides of the vertices of the new triangle. So triangle ABC would be similar to triangle. So ABC, so we're going to the small side, and then we're going to the next size. So it'd have to go from 12 to 14, and C has to be at the end because angle C we know is congruent to angle C. So it would be EDC. And the reason is side angle side similarity. And finding angle X, finding side length X, let's hold off. You guys do that, and we'll talk about that in class, next class. Okay. Practice. We'll do a few of these, maybe just the first one, but this you will finish and come into class on the next class with these done, this page. Each diagram shows triangle ABC and another triangle. None are to scale. For each problem, decide if they are similar. If the triangles are similar, write them in the correct order. Give the reason why they are similar. Oh, how come it just says angle, angle, and not angle, angle, angle similarity? You might recall the third angle theorem, which says if two angles of a triangle are congruent to two angles of another triangle, the third angles must be congruent. So you can either call this reason angle, angle similarity or angle, angle, angle. Angle, angle is just a drop shorter. So that will work fine. Hint, here's a big hint. Only 2 of the 9 pairs below aren't similar. So if you circle N, which is no, more than 2 times, you're making a mistake. Take your time. These can be tricky. All right, let's do the first one. So I see some of this got cut off. So this has to be A. This is a 70 degrees, 50 degrees, and C. So let's see. A, B, C, and D, E, F. No side information, but angles. This is 70, this is 50, this must be 60. If this is 60 and 70, that's 130. So 50 will be the leftover to match up to 180. So if you look at 70, 60, and 50, 70, 60, and 50. So these two triangles are similar by angle, angle, similarity. Again, you can put the third angle sign there, but you really don't need to. All right, now we have to match up. Angle A is 70, which match up with angle D, which is 70. Angle B is 50, which matches up with angle F, which is 50. And angle C is 60, which matches up with angle E. So it would be FDE. So the answer to this one was yes. Let's see. Let's go ahead and go up to letter C. Triangle ABC. Okay, now we want to match up the smallest to the smallest because, and again, all we're given for this one's our side info. So we check out is if 10 is to 15, 16. If 10 is to 16 as 15, which is the next size, biggest size, is to 24. And the largest is 20 and 36. So if we look at these, let's see. It looks like, let's see, 4 goes into 25 times. And 4 goes into 36 9 times. So that's 5 to 9. But if I look at this one isn't 5 to 9. And this one isn't 5 to 9. So the answer to this one is no, because you don't have side proportionality, or here, side similarity. Alrighty then, take your time. So we have found one of the no's, so there's one more no in here. Take your time. Let's see, what's this? This should be angle A up here. You probably have this in your notes, okay? All right. So take your time, and we will talk about the answers to this tomorrow in class.